So my name is Zach, and I work in the AI Center of Excellence and under Marcel, the AIOps group, and I'm currently the lead for the log anomaly detection project. And I wanted to go over and present some of the things that we've been building internally. So first, the use case. So we're building this log anomaly detector to help our internal customer with root cause analysis. We built it with unsupervised machine learning to identify the anomalies. We found that with machine learning, it's more of they give you a probabilistic answer rather than a deterministic answer, where probabilistic is generally saying that there's a percentage of being correct, and there's a possibility of having false positives. And we'll talk a little bit about how we built and designed some things to tackle those challenges. So our architecture, we run on Kubernetes, and we have basically the core component, which is the log anomaly detector, which pulls log data from Elasticsearch, trains, and then produces two models. I'll talk more in depth about the model part, but for now, I just wanted to kind of give it a high level overview of the system. And then once the models are trained, there's inference. The inference step also basically tags anomalies that are flagged as anomalies, and we store that in a fact store. We also generate a prediction ID so we can reference it later. And then which I'll talk about more in the next slide, which is about more in depth about the fact store. And then we have some monitoring and dashboard tools. We're using Prometheus and Grafana to get a dashboard to see the feedback that we're getting back from the fact store, as well as the metrics that are being generated from the model training. So we also in the inference step, we also send out messages to Elasticsearch, which triggers a alert to be fired off, and an email is sent to the user. And in that email, we embed a link, a hard link, where we use that prediction ID that was generated in the email. So when that user says, okay, this is not an anomaly and this is false positive, they can report that and give us feedback on that. And that link would lead to this particular page here, the fact store, where the anomaly ID would be in here, specify if it's an anomaly or not, and then you put some notes if you want to give us even more detail on why it's not an anomaly. And that's the high level overview of the system. We'll go into more in-depth detail on the models and the fact store as well. So the system itself is basically a Python program. It's a CLI. You can specify if you just want to train, or if you want to train and do the inference all in step together. You can provide a config map or a YAML to inject into the program, or you can specify environment variables. Both options are supported, and you can either pull data from Elasticsearch, or you can pull data from a local file, and then the sync that you would write to would be either Elasticsearch or a local file again. We may we're actually looking at maybe trying out Kafka next to try to see if we can get some more performance out of it. So the fact store. So the fact store came about because of folks were getting basically predictions that weren't necessarily right, so we needed human feedback to verify is this really an anomaly or not. And I'll talk a little bit more about the SOM model itself. So I can't take the credit for this whole system itself, as I had a great data scientist on the team, Michael Clifford, and I had an awesome architect, Bacek Pavlin, who also were involved in the design of the model training of the SOM model and the overall system. I've added the fact store, which was an additional component to this system. So I'll talk a little bit about the model training part. So there are two models. There is a word-to-vec model, and the word-to-vec model does the machine learning. And basically what it does, it learns the probability of words occurring with each other. We're using it in a very kind of unconventional way, but basically it's kind of like a pre-processing step. Basically verify, basically convert the raw log messages into vectorized representations. And once we're done with that, in the training step, the next thing that happens within the training step is we generate another model called the SOM model, self-organizing map. And what that does, it compares the vectorized representation of the words in the inference step, and basically it would basically train the model, and you would measure the distance of each inference message to the different nodes on the map, and then determine how like or unlike they are to the nodes on the map. Basically, it generates a real number. If it's normalized, it would be between 0 and 1. We have a threshold value. It's configurable. But basically, let's say consider if it's 3, 3 times the standard deviation plus the mean. That's an example of how we're calculating the threshold value. And then this is a standard way to determine if it's outside the bounds of normal behavior. If it's outside of the bounds of normal behavior, we would flag this as an anomaly. And anything that we would make sure we record it. Another additional thing that we have within the fact store is we use a Bloom filter to store the IDs of the predictions that were basically or the messages, and then we want to kind of check, has this message been seen before, when we're has this been reported as an anomaly, and then kind of try to prevent the user from getting duplicate emails and messages. For if he reported this was an anomaly, they should never get an email again. The next step after this is to pull in that data and then retrain the model with the false positives, and that's still in development. And that's something we're working on improving our model on. And yeah, so pretty much that is the flow of how this system works. The next thing I'm going to show you is a live demo, because I think slides are cool, but what's cooler than a live demo? So I've prepared an environment here for us. So I've deployed. So the database that's being used, we're using SQL Alchemy, and the database we're using is MySQL. Then we have Grafana and the fact store, which is a Flask application which connects using SQL Alchemy, and you can if you choose not to use MySQL, you can use Postgres, you can use other different databases. But for us, we just wanted to try it to use MySQL, and that works for our use case. So the trainer here is basically, you can kind of look at the system training. look at the pod itself, the log anomaly detector. We can see that it did send some it recorded some anomalies, and it sent some anomaly was found. This is the score that they found. The data scientists can also look at a Grafana dashboard, a little bit easier to look at. You can see how we're performing in terms of the system itself, and also we can kind of view some of the log messages that were recorded, the prediction ID, the score, and then the internal customer can give us feedback over here. So I'm gonna go and let's say I got this email. This was the particular prediction ID that was emailed with a link on in it. We would use query string, but then it would auto fill these values here. And basically, I would say, is this an anomaly? False. And why is this not an anomaly? Because it is just wrong. And once I submit that feedback goes in. It's now in the dashboard. We can see this anomaly wrong, and that's it. And pretty much we iterate through this and continue developing. And that's pretty much it for demo. Is there any questions? Anything that anybody wants me to dive into more in depth? We're glad to take any questions.
Not seeing any questions yet, but there really ought to be questions. And I'm guessing that the internal customer is perhaps OpenShift Online or OpenShift Dedicated. Am I right in my guess, or close?
So we have this internal machine learning platform where we have OpenShift and we have more components like Elasticsearch, Kibana, as well as Logstash and Kafka, and some systems are deployed up there, and their logs are streaming through Kafka and then into Elasticsearch. Some customers would have a requirement for some machine learning, and then we deploy this service as a service that they would utilize internally.
Yeah, so the internal customer, Diane, I think that was also your question, is a team within Red Hat that is maintaining build pipelines for containers. And they are using this tooling to identify anomalies in logs of their deployed system. And they are running on an internal deployed OpenShift instance. So basically, you could deploy the same setup that Zak just highlighted to any other team that also runs on top of OpenShift. And I think that's where we're trying to go from a prototype that Michael Clifford did as his internship last year. Then Vajek took it and sort of productionized it, and now we're trying to actually apply it to a running customer. And it's, again, all open source. You can find it on GitHub and deploy it for yourself. Obviously, it has some prerequisites to set up, so it needs to be on top of OpenShift, and it needs access to Elasticsearch where the logs are stored. But other than that, it's an open source project. And we're also in the process of collaborating with a Czech university in Prague to extend at least the research part of it. And it's coming out of the CTO office of Red Hat, so it's no way a productionized system, but it's some of our internal research topics that we're doing.
Zach, can you post the or go to perhaps the GitHub repo with the source code in it?
Yep.
That would be great. So are there any other questions, thoughts from folks on the call for Zach or for Brian or for Phil while we have them here? And if there are other topics you folks would like to hear about, we will be meeting again in another month post Red Hat Summit and KubeCon, so there'll be lots of busyness in between. So if you've got topics that you learn about there that you want to talk about afterwards, just ping Marcel or myself and we'll get them added to the next agenda.